A really warm welcome to you all. Thank you for joining our Raspberry Pi webinar, which is designed to help teachers and teams as you prepare for the competition. So our Raspberry Pi competition, which now runs in the UK and the Netherlands, is always an incredible display of the ingenuity of young people. Over recent weeks, as we've initiated the next competition, we've been absolutely delighted to see more than 300 schools have registered interest. And more importantly, 80 have formally entered our 9th UK competition. So that means that we're on track in 2021 for this to be our biggest year yet. So for our next competition, and by the way, you can register for this now through our website, we're challenging 8 to 18-year-olds to design technology to help create a positive future for everyone as we come out of an unprecedented period. And maybe if we just take a minute to reflect on the theme for this year's competition. So COVID-19 has been, we hope, a once-in-a-generation challenge, but we're seeing through this inspiring examples of where it's brought out the very best of humanity and unlocked our inherent ingenuity, whether it's from the rapid setup of Nightingale hospitals to manufacturing new ventilators in record time, through to the new vaccines that are our big hope for some sort of return to normality. So we are asking the teams that enter to imagine a world where we can develop a cleaner, more sustainable world, be better prepared for the unexpected. And as you'll see, a number of other themes there that we hope will be an inspiration for the young people entering this competition. What we found over the years is that we don't have to do too much. We can set a theme, and that then just inspires the young people to go off and look around them, be inspired by the real life situations that they see, and use that as the inspiration for their projects. So these are the kinds of things that we're asking them to think about as they embark upon their projects. So our competition culminates in an awards day, which is attended by PA clients and 12 ingenious finalist teams, which are shortlisted from the numerous entries that we get. And next year, this is scheduled to be on the 28th of April, 2021. We hope that this will be a return to our normal physical event, rather than the virtual event we had to run this year. The final date for entries, just as a reminder, is Monday, the 22nd of March, 2021. And I'll just talk a little bit about that finals event. So what happens there is we have a panel of expert judges who choose a winner from each of the 4 categories. And the award, the winning schools, £1,000, as well as a trophy and medals. And then we have a great networking event as well for our clients. So, you know, we've been running this event for 9 years to inspire students to explore STEM careers and be the next generation of problem solvers. We want to engage young people in the UK and also in the Netherlands to think about pursuing careers in STEM. And we deliver a range of activities in the lead up to the awards day, such as careers talks, mentoring, practical workshops. And at the awards day in itself, and in the lead up to the event, we're hoping to have STEM ambassadors to support teams and bring a fresh and inspiring perspective to STEM subjects. So what I'll do now is just give you a brief introduction to the speakers and the agenda for this session today. So we're very pleased to have, so you've got a picture of me, Anita Chandraker there. We've got Rick Cross, who is a director from the Raspberry Pi Foundation, and he's going to speak a bit about the Raspberry Pi Foundation story. We've got Monir, who's a teacher at Lady Eleanor Holles School, which has entered winning teams in the past, who's going to give us some inspiration of how they've approached it at their school. Then we are privileged to have two lecturers from Anglia, Ruskin University. So Lakshmi, who will talk about innovating for good inspiration, and Madhi, who will do the same. And then we're going to go on to hear from David Rees and Talmage, who are two of my colleagues from PA, who are going to talk about some real world examples of work that we do to inspire you about innovating for a better world. And I think, you know, by the end of that, we hopefully will have a little bit of time for some Q&A, and then we will close off this event. So I just wanted to just close really by saying, you know, I've been a sponsor of this competition since we started back in 2012. I am continually amazed by the ingenuity of the young people who enter this, and inspired by their creativity and passion. But for me, this is something like this is really successful if it stimulates even a few people each year to really think seriously about pursuing STEM, technology, innovation as they grow and develop their education and their careers. Now, one competition can stimulate some interest, but it then has to be sustained. And I think, you know, we all have a role in that. We've certainly found that the competition can be a great catalyst for that. And it's been really rewarding to stay in touch with people and see how they've developed. Now, some schools have made this part of this competition sort of part of their curriculum. It's something they do every year, and that's fabulous because that creates that continued focus amongst their community. But other young students have actually stayed in touch with us as they've progressed their careers and their education, and we've welcomed them back to do internships. We've even hired one of them. So, you know, hopefully this is a start for some of the people who will enter this, and we've all got a role in encouraging through it and making it something that they see as a longer term passion. So, you know, we also are, you know, this is, many of our clients are very inspired by what we do here and partner with us on the competition, through the competition. You know, they also get involved with running events for the young people, or by, you know, joining us at the finals day. So I mentioned, you know, we have a great expert set of judges on the day. You know, we've been privileged to have people like Rory Keflin-Jones from the BBC as a regular judge. We've had the NHS Digital CEO who's been with us several years and is committed to joining us again this year. So, you know, this is a topic and that really does inspire quite widespread interest and support, which we're very pleased about. So look, I think we can get into the call now, but if anyone has questions, please do share using the chat feature. Otherwise, you can email us and we will do our best to get back to you.
And good evening, everyone. My name is Monet Moudden. I'm a teacher at the Lady Eleanor Holles School. So at the Lady Eleanor Holles School, our girls successfully combine impressive intellectual endeavours well beyond academia. The annual PA Raspberry Pi competition has provided our pupils with the amazing opportunity to showcase some of the most incredible things that they are able to produce when they focus their ingenuity on the challenges facing society today. The first slide, as you can see there, is a picture of our winners in the Year 7 to Year 9 category in 2019. In 2019, the theme of the competition was on transport and travel. And after various ideas, the Brainy Baby Belt was formed. The team consisted of 4 Year 9 girls who got together to produce a product that makes children's car seats safer. The team used a nice blend of hardware and software to create their product. The group worked fantastically together and delivered a great presentation. There is a clear benefit to this product and it could make a difference in the real world. The team had also thought about next steps to take the product forward and presented their ideas in a compelling way. I put a quote together in reference to one of the members from the Brainy Baby Belt team, where she stated that our team started off as just one person, but then we all gradually joined in. It worked much better when we had all 4 of us working together. The team then traveled to Code Node, which was based in London, where they enjoyed a morning of robot building and code breaking activities, followed by speed networking sessions with industry experts and business leaders. Our second team that was also finalists in this year's competition in 2020 was Team Infratag. And this year, the theme of the competition was on sustainability living or sustainable living, which gave our pupils the opportunity to develop a piece of technology for the sustainable city of tomorrow. Team Infratag created a tracking device using GPS and infrared technology. The tag is used to track and trace lost bags and items of luggage. The judges commented in regards to the finalists, where they stated and highlighted the effort and level of teamwork and on the production of their solution to waste management and sustainable products for the future. From a quote from one of the members from Team Infratag this year, where she stated, "I found the PA Consulting PI competition a very inspirational journey as a whole. I have learnt about the importance of collaboration, how to code a Raspberry Pi, taking the initiative in a group project. It makes it possible for young minds to put their heads together to create new solutions for the future." Next slide, please. What I'm now going to do is talk about some of the tips in the success that we've had in the last 2 years, certainly for 2 reasons. One being that we've been able to create a club in our school, where the idea of creating the club was to firstly ensure that it was a club that was regularly attended, rather than something that perhaps is ad hoc or left towards a different part of what we offer here at the Lady Eleanor Holles School. So the first tip I would suggest and recommend looking at entering a competition like PA Raspberry Pi competition is to host it regularly. The second one, of course, is to host the event that will be inclusive. So it's offered for all ages and all abilities, not just some of the high abilities or those who traditionally follow the STEM related subjects, but host it for everybody, whether they pick the subject later in their schooling, whether it's GCSE or A-level, but to host it and host it as inclusive as possible, irrespective of ability or any other way of distinguishing the child. The third tip I would recommend offering is to allow the students to take a leadership role in this session, to be empowered to take responsibility in the project that they accomplish. How we offer it here at the Lady Eleanor Holles School is that we invite the girls in for the competition. We get them to review the rules, the criteria, and so on, and to brainstorm their ideas, but to take a real leadership role in that, giving ideas, sharing ideas amongst themselves, and someone who leads these sessions, just taking a role which requires me to be able to facilitate those requirements that they want to lead on. The fourth advice I would give is when you're running a club such as the Pi Club that we have here, that you create an environment that it's okay to make mistakes, because it's through those mistakes and that learning journey that brings the best out of each of the children that we run the club for. It's through those mistakes that there's no sense of accountability. They are not going to be judged for making mistakes. And certainly they are able to then find the best ways of overcoming those mistakes. And finally, the other tip I would recommend entering this competition would be to formally be informal, in that there is no assessment at the end of their experience. There is no judgment of what they can or cannot do, but the essence of being able to try new things out, not being afraid of making mistakes. So these are some of the tips I would recommend. And certainly once going through some of these suggestions, and by all means, these aren't exhaustive, do take a look at the web link that is available on the PA Consulting website, reading the criteria and the guidance very carefully. And if you haven't already, please do register your team. So the theme for this year is extremely exciting. The PA Raspberry Pi 2021 seems a promising prospect, and we again this year have already registered our interest in next year's competition. The theme is to design technology to help create a positive future for everyone as we come out of an unprecedented period of uncertainty. If you have any questions, do post them in the Zoom chat facility. Otherwise, you can also contact me on the details provided to you on this slide. Or of course, you can also follow us. We are available on Twitter at LEH Computing, where we regularly post our events and also our successes here at the Lady Eleanor Holles School. Thank you for listening and good luck in the PA Raspberry Pi 2021 competition.
Thank you very much for having us here. It's a great pleasure to be here. In fact, I've been in many other competitions before, like hackathon, but it is my first time. It's my first involvement in Raspberry Pi competition. I'm very excited about it. I've been a fan of Raspberry Pi and Raspberry Pi Foundation since the very first Raspberry Pi. And I believe they are doing a fantastic job to inspire and drive innovations, especially among the youngsters. Let me introduce myself. My name is Madhi Maktabdar. I'm a lecturer at the School of Computing and Information Science at Anglia Ruskin University. And together with my colleague, Dr. Lakshmi, she is a senior lecturer at the very same school, we are here to provide technical support for competitors. And well, both of us have years of experience in the field of image processing, Internet of Things, AI, and neural networks, and we are gladly here to provide competitor technical support and consultation, mainly for those of you who wish to involve with some sort of artificial intelligence in your projects, essentially. Although Raspberry Pi is not mainly limit you in any way regarding the programming language that you can employ to basically to develop your project, we do recommend to use Python as the way to go in this competition. There are tons of libraries with a huge support in Python. For example, if you want to do anything with image and image processing, if you want to use camera in your project, there are libraries like OpenCV, like Pillow, like PyCamera. These libraries, they allow you to basically to connect to your camera to do those image processing tasks that you wish to do. If you want to do anything with AI or AI related projects, there are libraries like TensorFlow, like Scikit-Image, like NumPy, like SciPy, or Scikit-learn. These libraries are fantastic. They allow you to basically deploy AI-related solution in your projects. If you want to work with GPIO, which is basically the port in Raspberry Pi, if you wish to link your project to Raspberry Pi, there are libraries like GPIO 0, or you can use the old school RPI GPIO library to basically to work with GPIO connectors. If you happen to deploy any sort of Internet of Things device as a part of your project, you can use technologies like RabbitMQ or LoRa or Zigbee. These technologies allow you to transmit messages to connect to your IoT device remotely. These are very lightweight, so you can use these solutions in a battery-powered device as well. So if you have any question regarding any libraries which is listed here, you can find Lakshmi or I, and we can provide you technical support in any of these libraries in Python especially. Here are some, I would say, rough ideas, rough project topics that you can basically use, or you can get some inspiration. Well, you can do project regarding air quality monitoring. Health monitoring is very popular nowadays. IoT devices, we have Internet of Medical Things devices. You can use those devices in conjunction with Raspberry Pi to create your projects. We have things like smart locks, motion detection sensors. You can basically innovate devices to check fevers or hyperthermia. It's a scientific word for fever. I've seen somewhere a drawing machine, which is very cool, or a 3D printed machine, which you can basically design using Raspberry Pi. Or there are tons of other topics. They are basically there is no limitation in what you can do in Raspberry Pi. It's a full-blown computer, literally. So you can do pretty much anything. And if you have any idea and you don't know how to basically formulate your idea, how to bring it, how to put everything together in a box, we can find me or Lakshmi to help you. Thank you very much.
I'm Rick, Director of Informal Learning at Raspberry Pi, and I'm just going to talk for a few minutes to give, first of all, a bit of background on the Raspberry Pi Foundation, and also to give some ideas on places to find some support and inspiration. So first of all, to talk about the foundation, its mission is to put the power of computing and digital making into the hands of people all over the world, empowering, providing support for learners who want to build ideas and address challenges that matter to them. And there's three main ways that we do that. First of all, we support teachers to deliver computing in schools. We do that through a huge set of training courses and learning resources as part of the National Centre for Computing Education. Secondly, we have the world's largest network of after-school computing clubs. I think there's something like 13,000 code clubs worldwide in more than 160 countries. And we support something like 180,000 young people a week to learn to code. And there's also a network of just under 2,000 active coder dojos attended by something like 55,000 young people. And the third thing is that we do research on teaching and learning, finding out what works, using the research to inform what we do, as well as sharing what we learn with the community. We've also obviously got a subsidiary, a slightly separate trading company that develop cutting edge affordable hardware to advance this mission and democratizing access to technology. And most recently, it's involved the release of the Pi 4, powerful enough to be a genuine drop-in replacement for a desktop PC. And actually, we've run a pilot recently to do just that, to get disadvantaged young people the technology that they need to learn at home through a pandemic. And also, a couple of weeks ago, the release of the Raspberry Pi 400. So it's a computer and a keyboard, which is very much built with teachers and learners in mind. As I say, released a couple of weeks ago and doing quite well so far. So that's us. We've been involved in supporting this competition from the beginning, I believe, and certainly we've been involved in the judging for a few years. And it's something genuinely special and something that we really believe in. I had the honor of judging the competition last year, and it was genuinely one of the highlights of my year. It was, as Anita and Monir have said, it's such an engaging, relevant theme, and it was just amazing to see the creativity, the ingenuity, and often the humor that learners demonstrated when they were showcasing their projects. So I had a lot of fun. And it's worth saying that I think by taking part in this competition, you're having an enormous impact on engaging and infusing young people, allowing them to see the enormous potential of the subject, and hopefully starting a lifelong learning journey. So thank you. There's a lot I could say about supporting and working with young learners on a competition like this. But for brevity, I think I'll boil it down to just a couple of things. Firstly, we have something like 250 digital making projects that you can find on our project site. So that's just projects.raspberrypi.org. And those projects are easy to follow, step-by-step guides to make a range of different things, you know, games, animations, robots, art, music, lots of different things. But the projects also have an end of project challenge, which give learners an opportunity to be a bit more independent, apply what they've learnt, as well as personalizing, tinkering, experimenting, and making the project theirs by taking it in interesting directions. So I think, I'm probably biased, but I think that's a great starting point for learners to get some nice ideas and to get some inspiration. And the second thing is that we run a yearly competition, Holles Projects, which is almost like a digital making version of a science fair, where teams come together and you know, they stand next to their creations and talk to others about them and things like that, which is, this year it's been held online. And the reason I mention it is because there's a really nice online showcase of projects that were submitted. So I think you can go to hollesprojects.org and there's a showcasing section. And again, I think it's a great place to get some ideas and inspiration. So that might be something else that's quite useful. So I think that's it from me. Thank you.
And hello, everyone. I think Anita's talked about unprecedented times in her part of her introduction. If we look at the last 8 months or so of this year, technology has presented opportunities and, dare I say, sort of requirements on us all to adapt, transform, and change what we do in different ways. And I suspect I'm preaching to the converted in the context of how you've been delivering educational services very differently to what you were 12 months ago. I just wanted to touch on a couple of examples over the last few months that we've been involved with. And just draw out actually one of them in particular, which I'll end on because it was my link into Raspberry Pi as well, and has got me involved for the last few years. But I'll start with the one on the top row in the middle, which is refers to the ventilator challenge. Boris Johnson, Prime Minister, raised a call to arms earlier this year that the health service required a number of ventilators if we were to combat the effects that COVID-19 was having on individuals, and indeed help those get better and recuperate as a result of it. And what that really meant was pulling together a whole host of requirements, specifications for ventilators that were at that stage not available. It meant engagement with manufacturers, not all of which would have had a history in a ventilator or clinical device manufacturer. So I remember one call I had with a colleague where he was standing in the middle of a car plant, which had been converted to make ventilators as part of the particular challenge. And that drew on a whole host of different skills and disciplines around manufacturing, logistics and design to try and meet the Prime Minister's requirements. I mean, for example, how do you get 40 million components from 21 countries together to try and get ventilators in weeks? And actually we did. So the very first ventilator was built within 4 weeks. And within 15 weeks, then 13,000 were put in place so that everybody that needed a ventilator was able to access one. So we rose to the challenge and reacted in that particular context. The second one I wanted to draw out then was Aurora, which is just to the right-hand side of the ventilator icon you can see with you. I'll not even confess to be an absolute scientist in this, but this is fundamentally about how you can use technology to reduce the spread of COVID indoors. So having with the ventilators reacted to how we deal with individuals who have lived or are dealing with COVID-19, how do we now stop its spread? And in a nutshell, it's all about bringing the benefits of the outdoors indoors. So think of it as a set of natural detergents that are used to purify a particular environment, we're currently using those and testing those in a number of UK hospitals to see if that can help reduce not only COVID or coronavirus-based viruses, but also things like E. coli, MRSI, and norovirus. The final one to touch upon, which is on the left-hand side of the slide, relates to Argenti. Argenti is the name of an offer which PA puts into the marketplace to use technology to allow individuals, the vulnerable individuals in our society, to live independently and safely. So currently, I look after around 20,000 individuals who are the most vulnerable in our society. And you can imagine the impact that that COVID-19's had on this particular year, where people have been unable to go and visit loved ones, care for loved ones, or indeed visit people in care homes. So three particular bits there that we've looked at using technology differently and in an innovative manner. We've harnessed the power of consumer technology. So we were the world's first adopter of Alexa technology a few years ago to be used in a social care context to deal with a whole variety of things around independence and social isolation. In responding to COVID, we worked on an automated calling service, which was to keep in contact and ensure that those that were on the shielded list were able to get the sort of services and the right services they required from their local authority. And then again, another first for us within PA, we've actually started using now a wearable robotic technology in care home scenarios, which allow care workers to support individuals and provide care to those who are in receipt of those services. So technology plays a part all the way through, our DNA within PA. My closing comment was my personal reflection, really. So I've been involved with Raspberry Pi for a few years now, and you've probably guessed that my focus has been on the use of technology in a care context. One of the themes a few years back was the use of care and use of technology in care, and also to increase independence. And I have to say, I was absolutely blown away by the solutions that the schools came forward with, recognizing that I'm doing this as a professional for my professional living. So much so that the winners in the year that I got involved with were invited to present on national stages at trade events for those that are involved with care technology. So, yes, we actually encourage the use of and the participation in the scheme, but ongoing, the opportunities for schools then to get further involved is, I would say, almost limitless. So, yeah, a very big fan, as you could probably tell.
Hello, everyone. My name's Dan. I'm an engineer working with PA Consulting. So I'm working quite close to where Rick is based, up in Cambridge. And I'm part of that same Cambridge technology sector. So just to show my credibility, there's my own Raspberry Pi. That's the one I own for myself. There's my son's CamJam Pi kit that he's in the middle of making at the moment. So these are all great projects that we can actually do at home. I was lucky enough to be one of the engineers who made the chips on the Raspberry Pi to start with. So I know many of the folks who are sitting in the engineering arm at Raspberry Pi and putting out great products. And just for me, I want to put out just a second shout out for the product that Rick mentioned, the Raspberry Pi 400. I'm a child of the 70s and 80s. I grew up with my ZX Spectrum, and some of you will have grown up with your BBC Micro or your VIC-20 or whatever you had then. And that was the computers that we cut our teeth on. And it was so much the inspiration for the people who wanted to make Raspberry Pi and say, maybe this generation can also do that. They can have real computers that they work with, and they can make real things with them. And eventually, maybe for some of them, it may be a career. And the Raspberry Pi 400 is going to do that for a whole new set of people, which is just fantastic. So since I've been in PA, I have been part of the group of people who help to look at the entries that schools send in. As we said, we have the awards day, which will invite some of the school teams to enter, and maybe I can give you a bit of insight into how we choose, because unfortunately we can't have everybody there. We have to choose. So what we're looking for from the teams, in a nutshell, is evidence. Of course, your school teams will have done some great works. Maybe you have the kind of STEM club that Monir described to us, which would be brilliant if you do. Maybe you're forming an ad hoc team for this competition. In all of these cases, and it's especially true when we're running our lives on these video calls today, aren't we? Here, we want to see, of course, what your teams have done, and we can only do that with evidence. So I'd say probably one of the very first things that we want to see, oddly, is we'd like to see your team. We'd like to see the people who are putting forward your great ideas. So Monir, the slides you showed us, we saw those 4 pupils who were at LEH who pushed forward their idea all the way to standing on that stage next to Maggie Philbin and holding up their card. And that's just brilliant, because we want to see their faces, we want to see their enthusiasm, and we want to see them talk about their idea for the world. We've got our theme for this year, and we'd like to see what your team has to say about that idea. What their idea is, why they think it's going to be important for the world, what's it going to do that fosters that theme of sustainability, reacting to this huge event which has hit us all and caused life changes across the country, across the world. Now, there's a couple of things that I think we would expect to see. It's a STEM competition, but unsurprisingly, as technologists, we have to be able to communicate, right? So actually, to some extent, we're looking for your team's skills in writing. We want to see that written description of what the project is. We want to see why it benefits the world, and maybe even, as David and Anita have alluded to, why it might have potential beyond the competition, and that would be absolutely brilliant. You all have a tool, I'm pretty sure, namely one of these, which you can use to record a video of your team. So I would thoroughly recommend that you set this up, put it on a little tripod or something like that. Make sure your light is right and your sound is right, so that you can see your team and you can hear your team, and just let them speak. I couldn't emphasize more what Monir said. It's great when we see it led by the pupils themselves, by the children who drive what they want to see in this. And when you see that, you can see people with ideas that they really believe in, and it's just great. That kind of feeling that we get when we see it at the other end is really what we're looking for here. So some of the other evidence we're looking for is very likely your team will have built something during your project. Some teams do software only, and that's fine. I should emphasize, if your team feels like it wants to write software, maybe if you want to go down the lines that Madhi and Lakshmi have spoken to us about, of machine learning, isn't that a great subject? If you want to do that, you can do a software only project. That will be great. As you may know, Raspberry Pi can be used to build real hardware as well, control real things. It has there's all the GPIOs that Madhi mentioned to us. Many teams will use that, and they will add a little bit of hardware to their Raspberry Pi, maybe to put sensors on it, maybe to put motors on it, maybe to put lights on it, something like that. And those are all really good. All of those are good projects. Rick mentioned the projects.raspberrypi.org. I think correct me if I've got that wrong, Rick. Great resource. Go and have a look at it for some inspiration if you want. Now, for whatever you make, we'll need to see the instructions. We'll need to see how you built it and how you use it. So those two things, they're separate. They're the instructions for using it and the instructions for building it. So please write them both down. We'd love to see your source code for it. For those who write software, write your software down, show us the source code. Now, there are loads of ways to do this. A really common way these days is to use GitHub. If you know what I mean by using GitHub, great. If you don't, and you want to use it, please come to one of us. There are lots of people on this call who can answer you and help you to use a web-based resource like that to upload your code. That said, though, we'll quite happily settle for a good old 1970s fashion printout of your code if that's where you're at. It's fine. We just like to see some evidence that you've written the code. If you want to use any of those resources that Madhi showed us, I'll take one close to my heart, OpenCV for image processing. Brilliant, really, really good. If you want to use that, you can drop that into the code. So we'd like to see your source code. We'd like to see the list of the software and the hardware you put in. So if anyone else wanted to build your project, they'd know what to go and buy, and they'd know what software to go and get. So that will help anyone who wants to read your project and to maybe go and build it for themselves. That's always really good. Now, about the last thing that I'd like to emphasize is that, of course, we'd like to see some kind of proof that the project works. Now, you can give us all sorts of different kinds of evidence for the proof of the project working. But I might highlight probably what I think the simplest way is to show it working is, once again, go back to this. As you film your team, it does no harm at all to include your project in the video and to say, here it is, this is it doing what we said it does. Now, that's absolutely great. If you want to provide other pictures, written descriptions, anything like that to show us that that your project really does do what you say it does, fantastic, that's great. As you'll probably appreciate with these things, much like any test, honestly, the more of these boxes you can tick, the more almost the more credit the team will get for it. I would love people to provide a video at all. If they're not great videographers, we're not going to judge people on the quality of their video recording, but we'd just love to see who they are, and we'd love to see their passion for what they do. So I think the last little shout out I'll give is that when you are if your team wants to build something real for this, as in a real physical object rather than just software, there are plenty of resources for this. The Raspberry Pi Foundation would point you towards lots and lots of vendors, but there are vendors who have an ecosystem with Raspberry Pi, and I'll just mention two: people like Pimaroni, people like Adafruit, from whom you can buy little pieces of hardware to help you do what you want to do. If you decide that you want to make a Raspberry Pi that I don't know, that drives a windmill or something like that, and you need a motor for it, well, one of those vendors can give you a little piece of electronics that you plug onto your Pi here, and you can make your motor go. And you'll get the code that goes along with it, and you'll be able to say, actually, with just a few lines of Python, you'll be able to get your motor going and then start doing the thing that you want to do. Some of this can be very daunting to start with, but there are people out there to help you. I absolutely promise you. When you look at it to start with, you can look at a computer that you might not properly understand and which you don't have much time to get to grips with, but there are lots and lots of people out there. It's one of the great things about the Raspberry Pi community. There are hundreds, thousands, tens of thousands of people out there who work with this. And if it's not one of us on this call, if it's not Rick or Lakshmi or Madhi or Monir, or me, then it's one of the people out there in the Raspberry Pi maker community who almost certainly can answer your questions.